Essentially, the James Webb Telescope has provided the most precise image of Proxima B in history, revealing breathtaking details of information about a possible exoplanet. It compels us, as we set out on an excursion through space, to uncover and discover Proxima B's secrets and whether it could be the next Earth. We ought to launch into the vastness of the sky, of space, where a mysterious planet exists in the habitable zone of its star, Centaurus Proximus. This planet is not just any ordinary rock. It's the truth. Proxima B is found a mere 4.2 light-years from us. This planet is covered in wonders and mysteries. Might it be an additional planet with oceans and life thriving at its surface? Regardless, wait, there's more. It isn't only Proxima Centauri B in that system with a red dwarf star around it. Proxima, its companion, Centauri C, and what else? Unknown mysteries of the system of stars. Maybe there's another companion that we haven't discovered yet. The method doesn't stop there. Proxima Centauri produces roughly the same amount of energy from its star, just like Earth does from sunlight. Could this truly mean that there's water on its surface and perhaps even life? As we look beyond our solar system, we encounter an entirely new world with exoplanets, planets that orbit stars other than the Sun. With 200 billion stars in the universe, the opportunities for exoplanets are endless. Some exoplanets even wander, freely, untethered to any star, like wandering space travelers. One of them, Proxima Centauri B, stands out as a particularly striking and enticing planet. With a year that lasts only 11.2 days on Earth and a distance to its star that is typically closer than Earth is to the Sun, indeed, one side of the planet is constantly washed in sunlight, while the opposite side remains in perpetual darkness. Now, let's look at the star that Proxima B orbits, Proxima Centauri. Proxima Centauri is part of the triple star system of Alpha Centauri. This system includes Rigil Kentaurus, also referred to as Alpha Centauri A, and Alpha Centauri B. These stars combine to form the star system closest to our Sun, Rigil Kentaurus, and the two stars, Alpha Centauri B, form a binary system known as Alpha Centauri A and B. These G and K-type stars are grouped together in Centaurus and are among the third brightest stars in the night sky, with a peak luminosity of under 2.7. Alpha or Proxima Centauri is another name. Centauri C is an M-type, or red dwarf, star discovered 21 light-years away from the other three stars, typically about 4 times the distance between Earth and the Sun. It is the closest star to us. Proxima, in fact, means the closest star in Latin. Additionally, it was found in 1915 by Robert Thorburn, an astronomer from Scotland. Despite being the closest star to us, it is not visible to the naked eye, with a magnitude that appears to be 11.13, which is much fainter than the limit for the human eye of 6.5. Anyway, don't let that fool you. Proxima Centauri is still a star worth studying. Red dwarfs like Proxima Centauri are among the most efficient in terms of energy production. They might not produce much power, however, internal convection takes place at their cores, keeping them shining for thousands of years. Generally speaking, Proxima Centauri will continue to be a main sequence star for another 4 trillion years. However, the habitability of a red dwarf star like Proxima Centauri is an ongoing debate. First, it is a flare star, which means that it has frequent, intense explosions. As a low-mass star, its habitable region would be significantly closer to it than the Sun's, which is anticipated to be somewhere between 0.23 and 0.54 AU. However, it is not as habitable as it seems. Proxima B is bombarded by intense ultraviolet radiation from its star frequently, more powerful than the radiation we get from our Sun. That's right. It's extreme to the point where even hydrogen atoms are stripped away, along with nitrogen and oxygen. But this isn't all. The fact that a planet is in close proximity to its star doesn't mean it can support life. There may not be a stable atmosphere on Proxima B, which is essential for regulating temperature and maintaining a water-rich surface. Without it, living creatures would be vulnerable to harsh space weather, making life almost unimaginable. So, while Proxima B might appear Earth-like on the surface, it is far from being able to support life. Scientists remain cautiously optimistic, as there are many factors that render it inhospitable. The goal to uncover the truth regarding Proxima B continues, and some still hold hope. One tool that has garnered the attention of astronomers is the James Webb Telescope. The result of years of anticipation, it was finally launched in 2018 and will help us determine if there is life on Proxima B. However, as with everything in science, things are never as apparent as they seem. Several alterations were required to ensure the James Webb Telescope provides precise images. As Abby Tabor, a theoretical physicist at Harvard, explains, if a planet like Proxima B can absorb light from its star, it can also emit it as infrared light. The James Webb Telescope was specifically designed to detect infrared light. It is able to take pictures of this light from the surface of the planet and look for patterns that might support the presence of an atmosphere or water. But what if there is an atmosphere on the planet that isn't good for life? The existence of an atmosphere does not ensure the existence of life. Ed Turner, an astrophysicist at Princeton University, cautions that Proxima B might be like Venus, with a thick atmosphere that is significantly denser than Earth's and extreme temperatures that would make it impossible for life to exist. The journey to unravel the mysteries of Proxima B does not come without its difficulties. While the James Webb Telescope holds promise, there are other factors to consider. With costs mounting, space researchers are under increasing pressure to discover methods for observing planets like Proxima B. Much is at stake, but the rewards are even greater. The opportunity to explore the unknown, to uncover the secrets of a distant planet that holds the potential for life, is a worthwhile pursuit. If the exoplanet were habitable, might we visit it one day? It is the exoplanet closest to us, which makes it so intriguing, much like exploring our own backyard. Even more exciting is that its size is roughly comparable to Earth's, and its position in the habitable zone suggests it could indeed have conditions appropriate for life. Proxima B's proximity also makes it an ideal target for our quest for life beyond Earth. Due to its proximity, it is an ideal candidate for missions across stars. Consider exploring this Earth-like exoplanet. Even though we are unable to go there yet, it is definitely on the agenda for future missions. It's one of the most thrilling projects in the field of space exploration. However, it's no easy task. It would require 75,000 years for Voyager 2 and other spacecraft to reach the Proxima Centauri system. Nevertheless, a solution has been proposed. Solar sails. These ultra-thin sails could propel a spacecraft to the Alpha Centauri system and Proxima in addition to it. This technology uses solar pressure to keep the spacecraft on course, eliminating the problem of running out of fuel. And here's something even cooler. This cutting-edge technology could provide insights into the possibility of life on other planets like Proxima B are fascinating. However, like anything ambitious, there are limitations. For instance, the presence of an atmosphere doesn't necessarily guarantee the presence of life. Proxima B may resemble Venus, with its thick, fiery environment that is hostile. Furthermore, the James Webb, oh my, telescope can detect such emissions if it only achieves a brightness of 5% of the daytime side. Now, 5% may not seem like a lot, but when it comes to a star that's generally dimmer than our own sun, it's quite significant. If Proxima B has advanced civilizations, they may reflect light with bright orbital mirrors, redirecting sunlight from the daytime to the nighttime side. How cool is that? There are numerous exoplanets awaiting discovery throughout the universe. These planets come in all shapes and sizes, with some being gigantic gas giants, while others resemble our own Earth. But how much do we understand about them? One type of exoplanet that has caught the attention of space scientists is the gas giant. These planets are similar in composition to Jupiter and Saturn, but are much larger. Some of these behemoths have been named super Jupiters, surpassing even our solar system's largest planet. However, that is not all. There are also gas giants, called hot Jupiters, orbiting close to their host star, existing in a scorching world with temperatures that could melt metal. Imagine taking a close look at such a planet, with its torrential downpours and extreme heat. There are gas giants, as well as exoplanets comparable in size to Neptune and Uranus. Among these are the hot Neptunes and small Neptunes, which are smaller and closer to their host stars than their gas giant cousins. These planets are frequently shrouded in mystery, thanks to their atmospheres being difficult to study from far away. And let's not forget the exoplanets that look like our own planet, Earth. These planets come in a variety of sizes, from smaller than our planet to twice its size. There are even super-Earths, which have masses more than twice that of our planet, but are less heavy than Neptune. One of the most captivating exoplanets recently discovered is Proxima Centauri B, which revolves around the star of the same name. This planet is known as a super-Earth, weighing an estimated 7 Earth masses. Although it is close to its host star, it is still too far away to be considered within the habitable zone. Not just Proxima Centauri B, it has a companion, Proxima Centauri C, which is much farther from the star. This planet has a period of about 5 Earth years in its orbit and was discovered in 2020 using Hubble data prior to recovery. What's even more fascinating about Proxima Centauri is that it appears to be an incredibly bright world, possibly due to the existence of a ring system. There's more to discover in the Proxima Centauri system. In 2019, astronomers detected a shift in the star's orbital speed, which could be the result of another planetary companion. If confirmed, this planet will carry the name Proxima Centauri D and will be roughly the size of Mercury or Mars. Imagine a life where the night sky is filled with stars as well as numerous additional planets, each with its own unique characteristics and orbits. The universe is full of surprises, and one of them is the exoplanet. With new discoveries being made constantly, it's an exciting time to be a space scientist. While we don't yet have an accurate count of exoplanets, we do know they exist, similar to how we know the stars light up the universe. However, exoplanets are not without their challenges. They are often hidden by the glare of their host stars, making them difficult to research. Still, with technological advancements, direct imaging of exoplanets is now possible. For an exoplanet to be directly imaged, it must be large enough for the telescope to see, sufficiently distant from its host star to not be obscured, and young, enough to be hot and visible from Earth. These restrictions limit the number of exoplanets that can be directly imaged. However, they provide an intriguing glimpse into the attributes and composition of these distant worlds. The exoplanets most frequently found are detected through the modifications they cause to their host stars. An exoplanet's gravitational pull can cause its host star to wobble, and this radial velocity can be detected by astronomers. The Kepler Space Telescope utilized the transit technique, which measures a star's light dimming when an exoplanet passes in front of it. This method has provided valuable information about exoplanets, including their size, distance, and temperature. Here are a couple of fun facts. Did you know that more than 22% of stars, like the Sun, have Earth-sized planets in their habitable zones, or that the TRAPPIST-1 system has 7 rocky exoplanets with water on their surfaces? Exoplanets similar to natural satellites in our solar system called exomoons can also exist. With more than 4,000 exoplanets discovered so far, we know they are abundant throughout the universe. Hot Jupiters, with their mass and rapid rotation, are the easiest to locate, but numerous other exoplanets remain to be discovered. NASA's James Webb Telescope is unveiling the secrets of the universe one discovery at a time. This exceptional telescope has been gathering data and capturing stunning images of the universe, revealing previously hidden wonders. It recently produced a revolutionary discovery that will alter our perception of the universe forever. NASA announced that the James Webb Space Telescope has discovered the first conclusive proof of carbon dioxide in the atmosphere of a planet outside our solar system. This discovery provides important insights into the world's composition and formation, offering us a look inside the mysteries of the universe. This gas giant orbits a sun-like star 700 light-years away, and this finding marks a significant step forward in the hunt for extraterrestrial life. NASA Administrator Bill Nelson stated that this discovery would provide us with a new perspective on the universe that we haven't seen before, sparking enthusiasm from astronomers and scientists worldwide. But that's not all. The James Webb Space Telescope has been busy capturing breathtaking images and gathering data about the universe in the ultraviolet. The light from the young emitting object, with the number 110 IROS-4, illuminates the cool, wispy cloud behind the orange spots and material. The cloud reveals starlight from far away, obscured by the ice in the cloud. This remarkable research was part of Webb's Ice Age project, which aims to study the genesis of ice from its formation to the development of icy comets. And that's not all. The James Webb Space Telescope has depicted the inside of a dusty disk encircling a nearby red dwarf star, capturing it for the first time at these light frequencies in the infrared.